Multiplication of polynomials requires careful application of the distributive law. Let's first review some of the properties that will be useful. We will use the commutative laws of multiplication and addition. These say that we can reorder factors under multiplication and we can reorder terms under addition. We will also use the associative laws of multiplication and addition. These say that we can regroup factors and we can regroup terms. To deal with powers of x, we will also use laws of exponents. In particular, we will need to multiply like bases by adding the exponents. Finally, we will use the distributive law. We will often use this law backwards to factor. A times B plus A times C equals A times the quantity B plus C. Let's start with the simplest polynomials and consider multiplying monomials. To multiply monomials, first use the commutative and associative laws to group the coefficients together and group the powers of x together. Then use the laws of exponents to simplify. Let's consider three examples. First, we want to multiply 3x squared and 5x to the fourth power. We reorder and regroup the factors to get 3 times 5 times x squared times x to the fourth. Then we simplify to 15x to the sixth. If we have more variables, we use the same procedure. Reorder and regroup the factors, putting the constants together and the like variables together. Then simplify. The coefficients don't have to be integers. With fractional coefficients, the process is the same. Reorder and regroup the factors, putting the constants together and the like variables together. Remember that to multiply fractions, it's convenient to factor and cancel as you compute. The 2 on the top cancels with the 8 on the bottom, leaving a 4 in the denominator. Also, the 15 on top cancels with the 5 on the bottom, leaving a 3 in the numerator. Now let's consider multiplication of a polynomial by a monomial. The process now is to use the distributive law and then simplify as before. We illustrate with 3 examples. To multiply 3x times the quantity x plus 2, we distribute first. We get 3x times x plus 3x times 2. Then we simplify the product of monomials as before to get 3x squared plus 6x. To multiply minus 2x squared times 3x minus 7, we distribute first. We get minus 2x squared times 3x plus minus 2x squared times minus 7. This simplifies to negative 6x cubed plus 14x squared. To multiply a trinomial by a monomial, we use the same process. Distribute the monomial to each term. And then simplify as before. Now let's consider multiplying general polynomials. The process is to carefully distribute and then simplify. Again, let's consider 3 examples. To multiply x plus 2 times x plus 3, we treat the x plus 2 as a monomial and distribute it over the x plus 3. We get x plus 2 times x plus x plus 2 times 3. We need to distribute some more. Now we get x times x, or x squared, plus 2 times x, plus 3 times x, plus 6. Collection of like terms yields x squared plus 5x plus 6 as our final product. Another example will help cement this process. Let's multiply 2x minus 3 times the quantity x minus 5. We will again distribute the first polynomial over the second. We get 2x minus 3 times x plus 2x minus 3 times negative 5. Distributing again produces a 2x squared minus 3x minus 10x plus 15. Collection of like terms produces a 2x squared minus 13x plus 15. Now let's repeat the process to multiply a binomial times a trinomial. We will distribute the 2x minus 3 over the trinomial. We get 2x minus 3 times x squared plus 2x minus 3 times 7x plus 2x minus 3 times negative 5. We still need to distribute some more. So distributing in each of the three terms, we get 2x cubed minus 3x squared plus 14x squared minus 21x minus 10x plus 15. Collection of like terms produces a 2x cubed plus 11x squared minus 31x plus 15. Although this process is straightforward, it does take some practice to distribute efficiently.